This is CPM Precalculus, Chapter 3, number 22. So here we have Julie, and she has a fresh cup of hot coffee that has a temperature of 180 degrees Fahrenheit. The temperature of the room is 70 degrees. So Julie's sitting in a room, her coffee is 180 degrees, the room is 70. Okay? So T is then going to be the number of minutes after Julie pours her coffee. Okay, so T is just time in minutes of how long it's been since she poured her coffee. D is going to be the number of degrees the coffee is warmer than the room temperature. Okay, so D is just like how much hotter compared to the room the coffee is. And then in this situation, D is equal to Km to the power of T for some constants K and M. So they're telling us right away that the relationship between the difference between the room temperature and the coffee cup is some exponential function with regards to time, right? So let's go ahead and look at this. Part A says 5 minutes after Julie pours her coffee, its temperature is down to 160 degrees Fahrenheit. Find K and M, and then write the particular equation for this situation. All right. So how do we do this? Well, remember we have the formula of our exponential function in terms of d is equal to km to the power of t. So do we have 2 points, right? Do we have points? If we have 2 points, then we can go ahead and solve for k and m, right? Well, 2 of our points, instead of x and y, right? Normally we have y is equal to a times b to the x power. But here we have d is equal to k times m to the t power. So instead of x and y, we have t and d. So instead of x comma y, we have our form d is equal to k times m to the power of t, and we have t comma d, right? This is what we have here. So we're given this scenario 5 minutes after Julie pours the coffee. So that means at t equals 5, right? Because t, remember, is the number of minutes after she poured her coffee. So at d is equal to 5, what is d? Remember, d is the degrees the coffee is warmer than the room temperature, all right? Well, d then is going to be how hot is their coffee at T is 5? Well, it's 160. So it's going to be 160 minus the room temperature, right? So the room temperature, remember, is 70 degrees, and that won't change. And 160 minus 70 is 90, all right? So T is equal to 5 minutes. D, then, we calculate is 90. So that gives us 1 point, 5 comma 90, all right? We only have 1 point. Is there any other point we're given? Well, actually, yes, we are. We're given the initial situation, right? The initial situation is at time is equal to 0, right? At time is equal to 0, what is D? D is equal to the initial temperature, 180, minus the room temperature, 70, which is 110 degrees, right? Let me just draw that. And that gives us the point 0, 110, right? Just like we have time, d, right? We have 2 points. Now that we have 2 points, we can go ahead and set up a system of 2 equations and solve for k and m. So let's go ahead and do that. This one gives us the equation, just plugging the values in. Here we have 110 is d, right? Because this is t comma d. So this right here is t, and this right here is d. So plugging them into this equation, we have d, which is 110, equals to k times m to the power of t. T we know is 0. Oops, 0, right? Likewise, let's plug this point in and get another equation. We get d, well, remember, this is t here, and this is d. So 90 is equal to k times m to the power of t, which is 5. So now we have 2 equations. We can use both these equations now to just solve for the variables k and m, right? So let's go ahead and, well, let's go ahead and like simplify these. M to the 0 power, we know is anything to the 0 power is 1. So this is 110 is equal to k times 1. Well, k times 1 is just k, so we know right away k is equal to 110. Likewise, we can go ahead and plug this value into this equation. We get 9d is equal to, plugging in k is 110, 110 times m to the 5th power. Now we just solve for m. We divide both sides by 110, right? Let's continue right here. 90 over 110 is just 9 over 11 equals, and the 110 over 110 cancel, equals to m to the 5th power, right? And we know how to go ahead and get m to the 5th power canceled. We just take both to the power of 1/5, right? These will cancel out, and we're left with m is equal to 9 over 11 to the 1/5 power, right? So that's our m. We could also write this as the 5th root, right, of 9 over 11, right? Or if we plug this into our calculator, just 9 over 11, we could write that as, and take it to the power of 1 over 5, right? And we can say m is equal to 0.96066056884. But I'm going to leave it as it is and just say this is m, right here. The 5th root of 9 over 11. And this is k right here. So then let's go ahead and write the equation d is equal to k times m to the t in general. So it's just going to be d, right, is equal to k. Well, k is 110 times m. M is the 5th root of 9 over 11. And this is to the power of t, right? And let's box this because this is the answer for part A, right? K and m we found right here and right here. And then we went ahead and plug them into our general equation, the exponential function d is equal to kmt. We know k, we know m. T is our variable, d is our output. All right, let's go ahead and use this in part D, because this asks, what does your model or equation predict for the temperature of the coffee 10 minutes later? So 15 minutes after it was poured. So 10 minutes later, meaning like after this initial 5 minutes. So we're looking for t is equal to 15, right? Or you can even say 10 minutes later, well, 10 plus our 5 here. Because remember, t was 5 in this part, 5 minutes. So that's 15. That's why they get 15 minutes. So at t is equal to 15, what is d? Well, d, we have this equation now. That's our model, or the equation. D is equal to 110 times the 5th root of 9 over 11 to the power of t, which is 15, right? So let's go ahead and just simplify this. We could put in our calculator right away. Remember, 9 over 11, the 5th root just means 1/5 power. So we have that to the power of 15. That's equal to, oops, I wrote this wrong. This is 110. So it's 110 times 1 over 5, then is multiplied by 15. So that's 9 over 11 to the power of 15 over 5. So 15 over 5, remember, is 3. Let's go ahead and bubble that. So that's the power of 3. We could go ahead and put this in our calculator. So I'm going to bring out my calculator. I'm going to say 110 times 9 divided by 11 to the power of 3. So that gives me 60.24 793388, right? So we might go ahead and say, well, this predicts that the temperature of the coffee is 60 degrees, 60.28 or 2479338. But no, this is not the temperature of the coffee. Because remember what D is. D is, again, the number of degrees the coffee is warmer than the room temperature, right? So D, given D, right, D is equal to the actual room temperature, the coffee temperature minus the room temperature. And we know the room temperature was 70 degrees. That's what we were given, right? The temperature of the room is 70 degrees. So we know here 60.24793388 is equal to the coffee temperature minus 70 degrees. So how do we find the coffee temperature? Well, we add 70 to both sides. Plus 70 to both sides. This cancels out, and then we're left with the coffee temperature is equal to, bring out my calculator, I'm just going to add 70 to what we have there, is equal to 130.24793339 degrees. So then the coffee at time is equal to 15 minutes. Coffee cup is 130.24793339 degrees Fahrenheit, right? Here's my final answer, right? So I can go ahead and let's round all of these numbers away, right? And since that was a 9 that we just erased, I'm going to have to round this 7 to an 8. Okay, so at time is equal to 15 minutes, the coffee cup is 130.248 degrees Fahrenheit. And that's going to be our answer for part B. And that's going to end CPM Precalculus Chapter 3, number 22.